You're welcome to our class in mathematics today, and we shall be looking at the topic SOD. Now, for us to understand SOD, we need to know what rational numbers and irrational numbers are. Rational numbers are numbers that are integers, and they are capable of being expressed as the ratio of two integers. Integers like 2, 4, 5, these are integers. And we said it can also be expressed as ratio of two integers, such as 6 over 3, 2 over 4, 2 over 3. So examples of rational numbers, we have proper fractions, you have your integers, you have your improper fractions, you have your mixed fractions, you have terminating and recurring decimals. They are examples of integers. While irrational numbers are numbers that cannot be expressed as ratio of two integers. For instance, so we said these ones are rational. While if you have root 3, 3 root 5, 4 root 7, these are examples of irrational numbers. So SOD is expression of irrational numbers. So we find out that when you will be solving SOD questions, we shall be dealing with expressions of irrational numbers. We have rules as well in SOD. If you have AB, this is square root of AB, where this can be expressed as root A times root B. For example, if you have square root of a number such as 15, it can be rewritten as square root of 3 times square root of 5. 2. We have a rule which is A over B, and that is A divided by B all in square roots, and it's the same as saying root A over root B. For example, if you have 7 over 23, that's square root of 7 over 23, it's the same as saying root 7 over root 23. 3. N into this root sign, and then you have your AB. Now it's the same thing as saying n root A multiplied by n root B. For instance, if you have 81 here and you have 4 over here, it could be written as this: 27 multiplied by 3, although this is not the simplest form that you can have. And number 4, we have A over B, where we have this n inside this root sign, and then we have the n as well inside this root sign. So for instance, if you have 27 over 125, it's the same thing as this: 327 over 3 125, and the cube root of 27 is 3, the cube root of 125 is 5. So we have this. These are the basic rules that we need to take notes before we solve some questions. Alright, let's look at basic operations in SOD. When we talk about basic operations, we are talking about addition, subtraction, multiplication, and division of SOD. Addition of SOD. For us to be able to add SOD, we need to ensure that the roots have the same value. For instance, if you have A root B plus C root B, this will be possible to add. But if what we have in these roots are different, then we can't add. So an example, if you have 3 root 2 plus 4 root 2, that would give, so 3 plus 4. Then since the root 2 and root 2 here are the same, you would pick one of it. So you are left with 7 root 2. Subtraction. In subtraction, it is also similar. You can easily subtract if the the irrational number inside the root are the same. So let's as say that we have a root b minus c root b again. If we have 5 root 3 minus 2 root 3, since the irrational numbers inside the root are the same, although there are times where you may have numbers that are not irrational inside, but you need to break it down to the simplest form. But in this form now, we have the irrational number in the root. So we will have 5 minus 2 first. Then root 3 is common there, so we have our root 3. So what does this give us? 5 minus 2, that's 3 root 3. Then we have multiplication of surd. To multiply surd, you could have different numbers in the root. So for instance, if you have 2 root 3 multiplied by 5 root 2, the numbers that are outside the root multiplies each other. That is 2 multiplied by 5. Then you have your root. We have root 3 times root 2. So that's 2 times 5. That gives 10. Then this is root 3 here and root 2. So root 3 times root 2, that gives root 6. So that is our answer. And then finally we have division. We are talking about division of surd. If you have a number such as 18 root 30 divided by 6 root 5. So this as well may have different irrational numbers. So all we need to do is just to have 18 over 6, which is 18 divided by 6. Then you have your root 30 over 5. So don't forget part of our rules. These two can be merged into a common root. So 6 here 3, 5 here 6. So we are left with 3 root 6. Alright, so we want to solve some questions under surd. Question 1. Express as complete square roots. 5 root 5, 11 root 2. Now if you look at this is more like the simple form or the basic form of a surd. Now to express as a complete square root, we look for how to move this 5 into this root. Now we know that 5 is the square root of 25. So if we make it as 25 in here, which is the same thing as 5, then multiply by 5. So to make it a complete square root, we will now bring this together, just like our first rule of surd. So 25 times 5 gives us root 1, 2, 5. Let's express 11 root 2 as a complete square root. So we'll follow the same process. Here we have 11 is the square root of 121. Then multiply by root 2. So we'll multiply the 2 and that will give us square root of 242. Question 2. We have to write in their basic forms. A. Root 18, root 96, root 512. To write root 18 in its basic form. Now if you look into this root, you'll find out that 18 is not a prime number. And so it is possible to have multiples of numbers that would give us a square root. So if we consider the multiples of 18, we have 2 times 9 as part of the multiples. So 2 times 9 will give us 18. That is not the only multiple. We could also have 3 times 6. We can have 1 times 18. But we are using 2 times 9 because 9 is a perfect square. And so this is same as saying root 2 times root 9. Root 9 is 3. So the basic form of root 18 is 3 root 2. We want to express root 96 as a basic form. So just like we said earlier, we are going to look for the multiples of 96. There are several multiples of 96. But the one that we shall use is 6 times 16. Why? This 16 happens to be the highest perfect square that we could have there. Because we could also have 24 times 4. But when we consider this, yes, 4 is a perfect square. Likewise is 16 a perfect square. But if we consider it closely, the biggest perfect square is 16, whilst 4 is smaller. So we'll go with the bigger perfect square. So the bigger, we'll have it as root 6 times root 16. And that will be root 6 times square root of 16 is 4. So the answer is 4 root 6. We are going to express root 512 as in its basic form. We look for the multiples of 512, and that would give 2 times 256. That's not to say there are no other multiples, but 256 happens to be the biggest perfect square to use. And so we'll have root 2 times root 256, and that gives us root 2 times square root of 256, and that's 16. So we have 16 root 2 as 5 root 2 minus 2 root 3, everything in square. We have to simplify this expression. This is more like having a minus b all squared. And this means a minus b, it will be repeated 2 times. A minus b, a minus b. And so when you have something like this, we are going to multiply this with this. So you can multiply it one after the other. That is having a times a, and then a times b. Then you now have b times a, and then b times b. And let's not forget that we have some signs that need to also correlate. So that is the format we are going to use to solve this. So we shall have 5 root 2 minus 2 root 3, and then 5 root 2 minus 2 root 3. And so we take this first. There's a positive sign here and there's a positive sign here. So 5 times 5, that gives 25. And then root 2 times root 2, that gives root 4. The number multiplies the number, while the one in the root will multiply the root correspondingly. And then this times this now. So 5 times, there's a negative here and there's a positive here. So that we have a negative. Then 5 times 2 is 10. 2 times 3 is 6. And then we have this multiplying this. Don't forget our sign here. So we have minus 2 times 5 is 10 root 6. And then this multiplies this. We have minus times minus, which gives plus. 2 times 2 is 4. Then 3 times 3 is 9. So next thing is, we have some numbers here that are perfect squares. So we bring them together first. Square root of 4 is 2. Then we have minus 10 root 6 minus 10 root 6. This can easily be either summed or subtracted. Now in this case, we have minus 10 root 6 minus 10 root 6. We have a common root, and then we have minus. So minus 10 minus 10, which is minus 20. And then root 6 is common, so we bring it there. Then plus root 9 is 3. And so 25 times 2 is 50, minus 20 root 6 plus 12. We collect like terms. These are the only two that can be added, but this can be added because this 20 root 6 is different. So we have 20 plus 12 minus 20 root 6. That is 62 minus 20 root 6. Just like saying this and this are not like terms. Just like having 2 plus 3a. Something like this. It can be added. Alright, so let's simplify this other one. 6 root 3 plus 2 root 2 all squared. So just as we did this, we have 6 root 3 plus 2 root 2 to repeated plus 2 root 2. So this multiplies this. That's 36 root 3 times 2 is 6. And then this times this, that will be plus 6 times 2 is 12 root 6. Here is 3. And so 3 times 3, that gives 9. 9, okay? And then we have this multiplying this. That's 2 times 6 is 12. 2 times 3 is 6 here. And then plus 2 times 2 is 4. And then root 4. We have some perfect squares here. So we have 36 times root 9 is 3. And then root 6 and root 6, they are common roots. So we can add them together. 12 plus 12 is 24 root 6. So the 6 is just picked. One is picked. It's not that the root 6 and root 6 are added to give root 12. No, we just have it as root 6. And then we have 4 times root 4 is 2. Okay, so we have 36 times 3. That gives 108. And then plus 24 root 6 plus 4 times 2 is 8. So we collect the like terms. 108 plus 8 plus 24 root 6. So we'll have 116 plus 24 root 6. Okay, let's look at this other example. We have 6 root 3 plus 2 root 3 into all in brackets 6 root 3 minus 2 root 3. This is different from the one we've done. This one has positive and negative here, and this particular expression is gotten from this, that's 6 root 3 all squared minus 2 root 3 all squared. This is difference of two squares. So when you have this, it could be expressed as this. So now for us to solve this, we don't need to do so much of multiplication, since what we have here, we have the same root, which is 3, and the same root here. So we go ahead and add, then subtract. So 6 plus 2, that gives 8, and then root 3. And then 6 minus 2, that's 4 root 3. And so we can now multiply. 8 times 4, that gives 32. And then root 3 times root 3, that is root 9. So we have 32 times 3, 96. Root 5 plus 2, and then root 5 minus 2. Now for this one, the signs are different, so we multiply just as we've been multiplying it. Root 5 times root 5, that gives root 25. Then root 5 times minus 2, that's minus 2 root 5. Take note of that. The 2 here only multiplies, there's 1 here which is not always 2, so 2 times 1 is 2. Then root 5 is written separate like that, and then plus 2 times plus root 5, that's the same thing as 2 root 5, and then plus 2 times minus 2, that is minus 4. Square root of 25 gives 5. If you look at this very well, they have a common root, but then we have minus 2 plus 2. Minus 2 plus 2 gives 0, and so everything here cancels out, and so we are left with nothing, and then we have 4. 5 minus 4 gives 1. This is the final answer. Let's simplify this expression. When we're talking about addition or subtraction of surd, we said they need to have common roots. So when we look at this, they do not have common roots, but we could find the multiples and look for how to derive their common roots. Root 2 is the simplest root that you could have. That is a prime number. So we write that. Then 5. 8 is not the simplest one. So we could have it as 2 times 4. And that will give us 8. Then we have 3, 18 as well. We could have it as 2 times 9. We could also have it as 3 times 6. But we'll not go with 3 times 6 because 3 and 6, there is no perfect square there. And there is nothing common in 3 and 6, which we can relate with this. And so we have 10 root 2 plus. This means the square root of 2 times the square root of 4. Then square root of 2 times square root of 9. 10 root 2 plus square root of 4, that gives 2. Then 3 root 2 times the square root of 9, which is 3. So from here, we will multiply what we can multiply. So 10 root 2 plus 2 times 5 here is 10 root 2 minus 3 times 3 is 9 root 2. So with this, we have common roots, and so we can add or subtract. 10 plus 10, that is 20 root 2. We just pick one, and then minus 9 root 2. So 20 minus 9, that gives 11 root 2, which is the final answer. And then we look at the expression 4 root 7 minus 2 root 28 plus 4 root 63. If we take a good look at this, they do not have a common root, but we could simplify it by having 4 root 7 minus 2. Then we have 4 times 7 plus 4 root 9 times 7. So we have 4 root 7 minus 2 root 4 times root 7 plus 4 root 9 times root 7. So 4 root 7 minus square root of 4 is 2. So we can have the 2 times 2, which gives 4 root 7 plus 4. Then this is 9. Square root of 9 is 3. So 3 times 4, that gives what? 12 root 7. So now we have seen that they all have a common root, which is root 7. So 4 root 7 minus 4 root 7, this cancels out, which is 0. And so we are left with 12 root 7. Alright, so we are moving on to rationalizing sod. When we rationalize because number one, we have a denominator which is a root, and also we look for how to eliminate the root such that we'll have an integer at the denominator. For instance, rationalize 1 over root 6. To rationalize 1 over root 6, we are rationalizing because of this root which we have here. So this is the numerator and this is the denominator. To rationalize it, we multiply both the numerator and denominator by root 6. In mathematics, this is of no effect because it's more like multiplying by 1. When this cancels this, we are left with 1. So we are back to our original question. But when we are multiplying it now, we shall see the effect. 1 times root 6 gives us root 6. Root 6 times root 6, that gives root 36. So the rationalized answer here is root 6 over 6. So we have successfully rationalized. B. We have to rationalize 1 over root 2 minus 1. When we have such, what we will do is to multiply both numerator and denominator by the denominator that the middle sign here has been inversed. How do I mean? So we shall say 1 over root 2 minus 1 multiplied by root 2 plus 1 over root 2 plus 1. So this is more like an inverse of this. And so we shall have 1 times all this. That gives us the same number, which is root 2 plus 1. And then this multiplies this. So just like we have how we multiplied before, root 2 times root 2, that gives root 4. Root 2 times 1, that gives root 2. And then we come to this, using minus 1 to multiply root 2, and that gives minus root 2. And then minus 1 times plus 1, that gives minus 1. And so with that, we shall have root 2 plus 1 over root 4 is same thing as 2. And then root 2 minus root 2 cancels out. And then we have minus 1. So our answer will be root 2 plus 1 over 1. This is the answer. C. If we have 3 plus root 2 over 3 minus root 2. Now we have to rationalize this. So what we have to do is to multiply both denominator and numerator by this same inverse of the denominator. So here we have negative turns to plus, but this sign here does not change. 3 times 3 gives 9. 3 times root 2 gives plus 3 root 2. Then this times this gives us plus 3 root 2. Then root 2 times root 2 gives us plus root 4. So we have 3 times 3 here is 9. 3 times that's plus 3 root 2. And then this times it gives us minus 3 root 2. And this times this gives us minus root 4. Before we collect them, we have 9. Then this and this have common roots. So that gives plus 6 root 2 plus 2 over 9. This 3 root 2 minus 3 root 2 gives 0. Then root of 4, which is 2. So we have collect like terms 9 minus 2 plus 6 root 2 over 9 minus 2, which gives 7. Okay, this is 9 plus. We have it as plus. So 9 plus 2 is 11 plus 6 root 2 over 7. We could leave this as our answer, or we could separate it. Now, you know that 7 is more like the LCM of these two. So to separate it, we could have it as 11 over 7 plus 6 root 2 over 7. So this and this are the same thing, and they could be taken as the answer. Alright, so D, rationalize 5 root 3 plus 4 root 2 all over 3 root 5 plus 2 root 2. Okay, so to rationalize this, we'll follow our procedure. 3 root 5 minus 2 root 2 over 3 root 5 minus 2 root 2. This is how we rationalize. So when we rationalize, you will find out that this square root here and this square root here gets eliminated. And so we have 5 root 5 multiplied by 3 root 5. We will have as 5 times 3. I think I would take it like this. 5 times 3, that's 15. Then root 3 times root 5, that gives root 15 as well. And then this multiplies this now. So 5 times 2 minus 10. And then 3 times 2, that's 6. Then we come over here, this now multiplies both. So we have plus 4 times 3, that's 12. Then 2 times 5, that's 10. And then we have this multiplies this now. So minus, which is the sign. Plus times minus is minus. 4 times 2 is 8. Then root 2 times root 2, that gives root 4. Over this times this. Now 3 times 3 is 9. Then root 5 times root 5, that gives root 25. And then this again times this. So we have minus 3 times 2 is 6. 5 times 2 is 10. Then we have this multiplies this now. 2 times 3 is 6. Root 2 times root 5, that's root 10. And then this times this now. That's 2 times 2 is 4 root 4. So we have all this. We have root 15, root 6, root 10, root 4. There are no common roots, but this can be simplified to have the square root because 4 is a perfect square. Now when we look at this, we have 15. 3 times 15 is what we can have as the simplest form. 2 times 3, 2 times 5. So there are no perfect squares we can have there. So we shall leave this like this. So we have this that can still be simplified. If you look at this so well, we have minus 6 root 10 plus 6 root 10. And so this and this will go. And this can be simplified. So we have 15 root 15 minus 10 root 6 plus 12 root 10. And then minus square root of 4 is 2. And then 2 times 8 is 16 over. We have 9 times square root of 25 is 5. Minus 4 times square root of 4 is 2. So we shall have 15 root 15 minus 10 root 6 plus 12 root 10 minus 16 over 9 times 5. This gives us 45. Then 4 times 2, that gives 8. 45 minus 8, that is 35. So we have 35 over here. So we could leave this as our answer, or we could have it as 1 over 35 multiplying 15 root 15 minus 10 root 6 plus 12 root 10 minus 16. Or we could have it as 15 root 15 over 35 minus 10 root 6 over 35 plus 12 root 10 over 35 minus 16 over 35. Find y if root 12 minus root 147 minus y root 3 equals to 0. We have to look for the value of y. Okay, so the idea here is to make all the roots have 3, just like we have 3 here. So we go ahead and make it like that. So we have 3 times 4 minus 3 times 49, which gives 147, minus y root 3 equals to 0. So the square root of 4 is 2, so we put 2 outside, so 2 root 3. Square root of 49 is 7, so we put 7 outside, so 7 root 3 minus y root 3 equals to 0. We can collect like terms. Okay, all of them have 3, but this has y, so we can't tamper with this. So we have 2 root 3 minus 7 root 3. They have a common root. So 2 minus 7, that gives minus 5 root 3 minus y root 3 equals to 0. Alright, so we bring this over here, and that gives, from the original question, this is meant to be plus. This is plus, this is plus, and this is plus. Okay, so we bring this over here. That means we have y root 3 equal to 5 root 3. So we can see the change in sign because there's a movement of this entire minus 5 root 3 from the left hand side to the right hand side. That is, it has crossed the equality sign. So when we compare this, we will notice that we have root 3 here and we have root 3 here, so they are common. So we can take this off. So the answer is 5. We are left with 5 as the answer. Okay, we have to simplify. Root 147 minus root 75 divided by root 48. So when we look at this, all the roots are big, and so we can look for how to get the prime numbers or to have the irrational form. So for this, we could have 3 times 49 minus 3 times 25 over 3 times 16. And so square root of 49 is 7 root 3. Then square root of 25, that's 5, then root 3. Then square root of 16, that's 4 root 3. So they all have 3 as the root in common. 7 minus 5 here gives 2 root 3 over 4 root 3. So we have root 3 common here. So this root 3 cancels with 3. 2 here 1, 2 here 2. So we are left with 1 over 2 as the answer. Okay, looking at this question. If 2 root 3 minus root 2 over root 3 plus 2 root 2 equals to m plus n root 6, find the values of m and n respectively. The idea about this question is to compare it with m plus n root 6. So when we have this, first let's rationalize. And rationalize it by multiplying both denominator and numerator by the conjugate of this denominator, and this is the conjugate. This multiplies this, we shall have 2 root 9. This multiplies this, we shall have 4 root 6. Then this times this, that would give root 6. This times this, that's plus 2 root 4 over this multiplies this, we shall have root 9. And this times this, we shall have 2 root 6. Then this times this, we shall have plus 2 root 6, and this times this, we shall have minus 4 root 4. Alright, so the square root of 9 here is 3. So 2 times 3 gives 6 minus 4 root 6 minus root 6. Here we have 1 here, and the roots are the same, so they are like. So minus 4 minus 1, that gives minus 5 root 6, and then plus square root of 4 is 2, and 2 times 2 gives us 4 over square root of 9 here is 3. So we have 3, and minus 2 root 6 plus 2 root 6. They have a common root, and here we have minus 2 minus plus 2, so they are similar, and so they cancel out. Then we have minus 4 times root of 4, which is 2. So 4 times 2 gives 8. We bring the like terms together, or we just say 6 plus 4, that gives 10 minus 5 root 6 over 3 minus 8, which gives minus 5. So we could separate this, and we would have 10 over minus 5 minus 5 root 6 over minus 5. So the 5 is more like the LCM of these two. And so 5 cancels this and gives us 2. 5 cancels this and gives 1. So we are left with, here we have a plus divided by minus, so we have minus 2. And here, minus divided by minus gives us plus. And then we have 1 root 6. So when we compare minus 2 plus 1 root 6 with m plus n root 6, we would say that m equal to minus 2 and this n, now they have a common root, so n here equals to 1. So that is the answer of m and n respectively. Given that p equals 1 plus root 2 and q equals 1 minus root 2, evaluate p squared minus q squared all over 2pq. So when we take a good look at this question, here we have difference of two squares and each of them represents something. So let us substitute them for what they represent. So we would have 1, okay, we'll have 1 plus root 2 squared, then q, which is 1 minus root 2 squared, all over 2 into brackets. Our p is 1 plus root 2 and q is 1 minus root 2. So with this means 1 plus root 2, 1 plus root 2, that is, this has been expanded, minus 1 minus root 2 and 1 minus root 2. So this has been expanded into this, over 2 into bracket 1 plus root 2, 1 minus root 2. So we shall use this to multiply this and then this to multiply this. 1 multiplied by 1, that's 1. 1 times root 2, that's root 2. Then this times this gives root 2. And this times this gives, so root 2 times root 2, that's root 4. And square root of 4 is 2. Okay, so we have minus. Then 1 times 1 is 1. 1 times root 2 is minus root 2. Minus this times this, that will give us minus root 2. And then minus root 2 times minus root 2, that will give us plus 2. Because root 2 times root 2 is root 4. And square root of 4 is 2. Over, then this multiplies this. So we have 2 into brackets. 1 times 1 is 1. 1 times root 2 is minus root 2. Plus root 2 times 1 is plus root 2. And this gives us, so root 2 times root 2, that's root 4. And square root of 4 is 2. Alright, so this cancels this. So bring it together. We have 1 plus 2, that is 3. Root 2 plus root 2. So we have 1 here and we have 1. So 1 plus 1 gives 2. And then we pick one of the root 2 because it's common. So bring this in brackets, minus, then we will have 1 plus 2, that's 3. Then minus root 2 minus root 2, that's minus 2 root 2. Over, we have this. So minus root 2 has cancelled plus root 2. 1 minus 2, that gives us minus 1. Okay, so we would have 3 plus 2 root 2. We want to remove the brackets. Minus 3, minus times minus is plus 2 root 2 over 2 times minus 1 is minus 2. Okay, so we have 3 minus 3, that is 0. Then we are left with 2 root 2 plus 2 root 2 over minus 2. So 2 plus 2, that's 4 root 2 over minus 2. So 2 cancels 2, we have 2 left here. And then we have plus divided by minus, so we have minus 2 root 2 as our final answer. Here comes another question. Find the square roots of 5 plus 2 root 6. Now, looking at this question, this is just like saying we should find the square root of 16. We all know that the square root of 16 is 4. That's plus or minus 4. Now, the same thing goes for this. We are asked to find the square root. So if we say the square root of 16 is 4, then if we say 4 squared, what does that give us? It gives us 16. Likewise, we could say that let the square root of 5 plus 2 root 6 be equal to square root of a and square root of b. We are using this unknown. We do not know them. So we are using this as to represent the square roots. And so if that is the case, we would say that 5 plus 2 root 6 is equal to square root a and square root b, all squared, just like we did. So we squared this in order to get this. If what we have here was minus is what we are going to have here. But in this case, we have positive sign there. Alright, so let's proceed. We shall say that we would expand this by having root a plus root b, and then root a plus root b. Root a times root a, that is equals to a, just like root 2 times root 2 equals to root 4, and root square root of 4 is 2. So here is a. Then root b times root b, that gives plus root ab. And then root b times root a also gives us root ab. Then root b plus root b, that gives b as well. We can collect this because they're like them. We have one here and one here, so that is going to be a plus b plus 2 root ab, and this is equated to 5 minus 2 root 6. If you look at this so well, we could say that, all right, we have plus here. If you look at this closely, we could say that 5 is equal to a plus b, that is, they are synonymous. And we could also say that 2 root 6 is equal to 2 root ab. So with this, we have 2 common here. So 2 cancels 2 and this. So we are left with 6 equal to ab. So we could take this first one as our equation 1 and take this as our equation 2 and solve them simultaneously. So from equation 1, let's make a the subject of formula. So a will be 5 minus b. We shall substitute 5 minus b as a in equation 2. So we shall have 6 equal to 5 minus b into brackets b. So in this equation, we will remove a and put 5 minus b, since 5 minus b is equal to a. So we've replaced it. So we shall have 6 equal to 5b plus b squared. B squared plus 5b. Alright, so here is minus, so we shall have this as minus, and here we have minus here. Okay, so we have minus here. Bring this to this side. We shall have b squared minus 5b. Let 6 remain here. So we have plus 6 equal to 0. This is a quadratic equation, so we solve it using factorization method. So we shall have b squared. What is common? We would use minus 2b minus 3b plus 6 equal to 0. So b into brackets b minus 2 minus 3 into brackets b minus 2 equals 0. So b minus 3 and b minus 2 equal to 0. So b minus 3 equals to 0, and hence b equals to 3. And b minus 2 equals to 0, that's b equals to 2. Now with this, we can say that if b equals to 3, then a will be what? So we shall substitute 3 into b in this equation 2. So we shall have 6 equal to a times 3. Therefore, a will be 6 divided by 3, and that is 2. And if b is equal to 2, it will be, we will substitute the b with 2. So we shall have 6 equal to a multiplied by 2. So a equals to 6 divided by 2, and that's 3. So we have our answer. So if b equals to 3, a equal to 2. Or if b equal to 2, a equal to 3. So we'll find out that the square root of this particular equation is square root of 2 plus square root of 3, or square root of 3 plus square root of 2. This is the final answer. Now I believe we could also check this. We are saying root 2 plus root 3 is the square root of this. So to prove it, we shall square this, or we can square root 3 plus root 2. Since we know that these are actually the same, it's just a matter of exchanging. So that will be root 2 plus root 3, and then root 2 plus root 3. Root 2 times root 2, that gives root 4. Root 2 times this, that gives root 6. This times this, that's root 6. And this times this gives root 9. Square root of 4 is 2. Then root 6 plus root 6, that's 2 root 6. Root 9, that's plus 3. 2 plus 3, that gives 5 plus 2 root 2. hence the answer. To find the value of x for which root x plus 5 equals to 5. To solve this question, we are looking for the value of x. We have square root here, we have square root here. To remove this square root, we shall square both sides. So square both sides. So we shall have, now when we square both sides, we have squared here and we have squared over here. Now when we square this, we shall have something like this, plus x plus 5 multiplying x plus 5, then 5 squared, which is 25. So when we square this, we are going to repeat this 2 times and we shall use it to multiply each other. Alright, so we use this to multiply this first. So root x times root x, that gives x. And then root x times square root of x plus 5, that gives plus, the x comes in here to multiply, so we shall have x into bracket x plus 5. And then we use this to multiply this, we shall have the same thing, x into bracket x plus 5. So this x multiplies the x plus 5 inside, and all of them are sharing the common root. And do not forget our rule of sort. And then this multiplies this, we shall have plus. Now this multiplies this will only lead to the removal of the root sign, and so we shall have x plus 5, everything equals to 25. Now we would have x plus this and this could be brought together. Okay, we can remove this, we have 5 here. This and this could be brought together. It's just like you have root a plus and root a, that gives 2 root a, and that's what is going to happen here. So we'll have 2, since they are the same thing, 2 into the root of x plus 5 plus, we have x here. Let's bring this 5 to the other side. That will be 25 minus 5. So we can collect this like term. X plus x gives 2x, and then plus 2 into brackets x plus 5 equal to 20. We have 2 common here, so let's divide through. Divide by 2. So when we divide everything here by 2, we shall have x plus 5 equal to 10. Let's take this x over here, so we will have root x plus 5 equal to 10 minus x. Now the idea now is to look for how to remove this root here. So we square both sides again. Square both sides, and we shall have, when we square this and you square this square would take off the roots. So we're left with x plus 5 equal to 10 minus x, 10 minus x. And this gives us x squared plus 5x. 10 times 10 is 100. 10 times this minus 10x. X times this minus 10x. Minus x times minus x, that gives plus x squared. So x squared plus 5x is equal to 100 minus 10x gives minus 20x plus x squared. We collect like terms. So when we bring this x here, we find that we have x squared minus x squared, and then we have plus 5x plus 20x equal to 100. This cuts this, so we are left with 5x plus 20x, that is 25x equal to 100. We divide both sides by 25. So 25 cancels 25, and here we have 4. So the value of our x is 4. Alright, we have to solve this equation, which is square root of 2x squared minus 1, all of them inside the square root, equal to 7. Now this is quite simple. What we do is we square both sides. When you square both sides, we'll have 2x squared minus 1 all squared, then 7 squared. This square cancels this root, so we shall have 2x squared minus 1 equal to 7 times 7, which is 49. So we have 2x squared equal to 49 plus 1. So we collected like terms. So we shall have 2x squared equal to 50. Now with that 50, you divide both sides through by 2. So you are left with 25. So x squared here equals to 25. So x equal to square root of 25, which is plus or minus 5. That is the answer.